And let me know if it didn't go through, because looks like the system allows me to record lectures, and I guess we did it last time. And yeah, so I started recording just now. So thanks for reminding. So as usual, I will email you this recording a little later when I get it from Zoom. So looks like we can continue enjoying the section now and being recorded at the same time. So they have various examples, and I was going a little slower in this section because it's quite different compared to what you usually see in math classes, right? So those different bases, like example 3, we also looked at last time. It was a number in the base 16. So what we were supposed to do is just take powers of 16 here, right? So for E, C, and 7. So since E was number 14, so to write this number in the base 16, I need to put 14, and since it's a third digit, so I'll be multiplying it by 16 squared, plus C, which is 12. So I get 12 multiplied by 16 to the power of 1, right? And finally, last digit, which is 7. So I get 7 the way it is, multiplied by 16 raised to the power of 0. And then we can actually see what this number is supposed to be in our favorite base 10 system. In fact, I guess it's always a good idea to be able to convert things to base 10. So let me, oh, there is a calculator. So good, it's 14 times by 16 squared. So you don't have to calculate what 16 squared is, just put it all here in this Desmos calculator, right? And it'll take care of it for you. And then 7, the last digit, I guess don't have to multiply it by 16 to the power of 0, which is get 7, because it's times 1, right? So it looks like here we have the answer. It's equal to 3,783. And we already saw that, I guess there is no way we can intuitively guess what type of number they have here for us, but just need to put all these powers of 16 in a calculator. So let us check this out. Looks like, yes, they do put that same exact 3783 for the answer. So it never hurts to double check your answers, of course, because otherwise, what's the point of doing problems, right? If you do them incorrectly. So try to maybe sometimes not to do that many problems, but better to do problems correctly. So what I'm talking about is redo exercises done in class, because you already know what the answers are, and then you'll be able to definitely visualize the results. So we saw all this last time, and I guess the goal of today's class is to refresh. And since the material is quite unusual, I guess we can go over it again. Why not? So there are various other bases that they have here. For example, if you try to look at the example 4 that has base 5, so we write everything with powers of 5, right? And every digit then will be multiplied by some power of 5. So it looks like here we have a little number, which is base 8. Actually 8. So they converted to base 5, but they went backwards. So we also did that on the last quiz as well, remember? So going backwards means I need to write this number with powers of 5. And I see that the closest to 8 will be not 5 squared, not 5 cubed, because that's very large, right? It's already 25 or 125, so we go 5. So if we rewrite it as a 1 times 5 plus the remaining is 3 multiplied by 5 to the power of 0, right? So we need powers of 5 here. And once we were able to present it in the form of sum of pieces that have powers of 5, then we take those numbers such as 1 and then 3 and compose from them 1, 3, base 5. Again, I deliberately don't want to use 13 because it's really not a 13, it's really 8. But in a base 5, it looks like 1, 5, and 3 ones, or 3 5s to the power of 0, right? So let us try to do some problems at the back of the book, as well as, if you please remind me what exercise we had for the quiz. I think I probably created my own or something, right? There was some exercise I remember was supposed to write it in the base 2. So we needed to write base so we had 2 and we needed to write it in the base 2, right? Thank you for reminding. So in the base 2, if the number is, oh, we did 23. Okay, thank you, thank you. So if you have number 2 and you need to write it with powers of 2, and notice that the powers of 2 should be either zero power or first power, right? And again, in the base 2, we have only digits 0 and 1. So we cannot use anything like that, right? So there is no such digit. So it's either 0 or 1. And then 2 I write as a sum of 2 pieces. One of them will be a digit 1, right? And there is nothing left after you take that 2 by itself. And that's the number that I have, 1 from here and 0 from there. So in the base 2, it looks like 1, 0, because there is 1 first power of 2 and no 0 powers of 2. And that's what we should have here for the answer. In fact, I guess it'd be probably convenient to go back to a little table that they provided in the very beginning of this section. And I believe here they have all those numbers in a base 2, and looks like we have 1, 0, which is actually the one we produced, right? So, well, I guess we little by little getting used to this. And let me try one more exercise here in this section. If you have any particular problems in mind, please let me know which one you prefer me to do here on the exercise set 4.2. Looks like we have only one little column for practice. And I told you that you don't have to worry about the second column of problems. I guess they're not very hard, but they're just, I think, good enough that you do problems from first column. So in the base 4, thanks for questions. So if anything else, please let me know if you have any other problems in mind, but I'll start with 29. So it looks like here we are dealing with powers of 4 because the base is 4, right? Now, if I go with 4 squared, that's already too much because it's 16. It's bigger than the number we have. Well, so when I try to rewrite this 13, then I need to see how many 4s it has. And it looks like if I take 3 times 4, right? 3 times 4 to the power of 1. And then what remains after we get that 12, it'll be another 1, right? Multiplied by 4 to the power of 0. So I take these digits, 3 and 1, and get the number in the base 4. Again, in the base 4, we don't have digits such as a 4 or 5 or so forth. So those are the only digits possible. And once you get larger than 3, then it already starts using, again, that 0, but for the probably first position. So we write, again, numbers in various bases. I think last time I promised to do an exercise, the last one in this little group of problems for you. I think 47 or 48, so maybe I can do, let's say, 47. They say, write this in a base 7. Okay, so in a base 7, we have, again, powers of 7. So there's 7 first power, 7 to the second power, which is 49, right? 7 cube, which is going to be, let's see what it is. I guess I just use calculator. You don't have to think too hard, so we can just put 7 power of 3. So that's 343. I guess the number they provide us with is large enough, so maybe I can also get a couple of more powers of 7 then. So if I raise 7 to the power of 4, then I can have 2,401, right? 2401. And I also want to try 7 to the power of 5 for just in case. And this be 5, which is 16,000 already. I guess that'd be large, right? 16,807. Okay, so let us get back to the page that has number 1346. Oh, actually 1599. 1599. Okay, so looks like I don't have these 4th and 5th powers, but cube. And the way to go with 1599 is to see how many times 343 is gonna fit in that particular number. So I need to decide that 343, which is a third power of 7, right? And then I need to see how many times 49 will fit. And then 7 itself, and 0 powers. So some coefficients may be not present, maybe zeros, but again, we need to actually try, and the way to go is divide. So it looks like what I need is to divide 1599 by 343, and see it goes 4 times, and little something, right? So what do I do then? Well, looks like I need to put a 4, right, times, and once it's multiplied by 4, so what I do is I actually go ahead and multiply the number 4 and 343 and see what's gonna remain. So once we have multiplied, we got 1372. So the reason why we need to divide it by 343, because that's a power of 7. So we need to divide by powers of 7 to see how many times they fit. So here's the next is 49. So for example, when I get to the remaining portion, so I already have 1372, then would be a remaining part of that 1599. So if I look at 1599, and if I subtract that 1372, again, we had to use that little number 7 cube. So since we're in the base 7, we concerned with powers of 7. So we're dividing it by powers of 7. So once I produced the remaining number, which is 227, please notice that 343 is already larger. So now next step will be to take this 227 and divide by next power of 7, which is 7 squared, and see how many 7 squares or 49s are going to fit in it. You see how it goes? So we get the digit next to it, and we see there are 4 49s that fit into what remains, which is 227. And now we go with the there's some question about exercise 13. Well, let me finish with this, and definitely we'll talk about that. So anyways, when you take 4 now and multiply it by 49, you got 4 times 49, you get 196. So this be another piece. So this is 196. And notice that after I add this 196 with 1372, right, I'll see what remains for this first power of 7 and 0 power of 7. So yeah, it is kind of tedious. And I would recommend that one actually, well, again, does the same problem again, maybe a little later today, because indeed these are not obvious exercises. So please notice that what we do is we have chunks of this 1599, and we already have 2 of them. So we had first that deals with power of 3 of 7, and second piece that deals with power of 2 of 7. And together they give us this 1568. So what remains here in 1599, so how far we need to go to get to 1568. Well, I guess I just need to minus these again, 1599, 2 nines, and 1568, right, the one above. And I see that 31 is left. So now the next step will be to have 7 fit into that 31. So it looks like we first try to fit 7 cubed. Into what remains, we fit 7 squared, which is 49. Now notice the number we produced is less than 49. So now we go with the next digit, with 7. And I guess I can see that 7 times 5 is 35. That's too much. So 7 times 4, right? So if I go 7 times 4, which is 28 here. And once I try to fit 28 into 31, looks like it goes 4 times, right? And then when I subtract this 28 from 31, what remains will be 3, right? So what remains will be 3. And this means that I just go 3 times 1, because that's 0. So the point of story is to break those numbers with powers of 7. And finally, write the answer that is composed from first digit. So it's 4443. So this number is one that is in the base 7. And of course, we absolutely need to say that we are dealing with a base 7, because otherwise, how would someone know that, right? So we have various interesting bases. And the answer is, of course, unique. So if you write the answer in a base 7, that's the only way to write the answer. Analogously, if somebody asks, what about exercise 13? Is there only one answer? Of course, the only one answer, because that's I guess we have only one answer for all math problems. So if you wondering about this number in a base 16, so we can do this exercise, of course. So we have 2 multiplied by 16 cubed, right? Plus next digit is 0, 16, multiplied by 16 squared. So we just break this in the powers of 16. Next is going to be 9 multiplied by 16 raised to the power of 1. See, powers of 16 just keep on decreasing all the way down to 0. And then finally, 6 multiplied by 16 raised to the 0 power. And then I need to put this all in the calculator, I guess, and see what the actual number is if we write it in the base 10. So I go with 2 times 16 cubes. So just enter all that in the calculator. Then 0 times 16 squared, I don't have to enter because it's times 0. So next will be 9 times 16, right? And finally, plus 6, because 0 power of 16 is 1. So we got the number, and this is actually 8,342. So it turns out if you have number in some particular base, usually it's convenient to turn this number to the base 10 and then do something you need, which actually appears in the next section. So what do I need? Well, it turns out the next section is talking about various operations on these numbers in different bases. Let me go to first page. So, for example, if I look at the first example here that wants me to add two numbers in the base 4, well, turns out you could just turn both of them to base 10 and add. So you can say 33 in the base 4 is nothing else but 3 times 4 to the power of 1 added with another 3 times 4 to the 0 power. So you could write this as a 12 plus 3, which is 15. And analogously for the other, for 1, 3 in the base 4, you can also write this with powers of 4. So 1 will be multiplied by 4 to the first power, and then 3 is multiplied by 4 to the 0 power. So when you add these, you're going to get something like 4 plus 3, right, which is 7. So you actually add these two numbers, which is 15 and 7. And when you add 15 and 7, what you get is 22, right? But again, I need to rewrite this in the base 4. So if you try to write 22 in the base 4, looks like 4 squared, which is 16, is going to fit in it, right? So it'll be 116 plus what remains is going to be 6. So I will put 6 as a 2 times 4 to the actually 1, right? Because it's 38. So it's 1 times 4 to the first power. And then what remains will be 2, right? 16, 4, and 2. That's my 22. And I have just 2 ones in it. So what you can do is write this result back in the base 4. I just want to use different colors so we better see. So it's 1, here's another 1, and here's 2. So actually the result will be a 1, 1, 2 in the base 4. Well, actually that's not the way they do this exercise, but I decided to show it to you anyways, because that's something we have been already doing in the previous section. So what they do here is they produce exact same result. As you can see, it's also 1, 1, 2 in the base 4, but they don't convert these numbers to the base 10. Well, I think it's probably convenient to convert to the base 10 and then add the numbers and then convert it back to base 4. But they're not doing it. They just add in these numbers in the base 4. So how they do this? Well, they add 2 3s, and that's 6. But there is no such a thing as 6 in the base 4, right? So in the base 4, we have only digits. I think I should clean this a little bit. It's too much mess. So in the base 4, here we actually have only digits 0, 1, 2, and 3. You can see it left over from previous examples. So I don't have a 6. So I need to, instead of 6, so instead of 6, which is actually not possible in the base 4, I write 1 first power of 4 and 2 second powers of 4. So notice that 1 first power of 4 will be carried up here, That's why they put 1. It means that we already have first power. And what we write is 2 because it's actually looks like 1, 2 in the base 4, the number 6. So we write the last digit and we carry first digit over to the place of, I don't want to use word tens because we don't have tens, we have first power of 4. So actually, when you have this 1 and 3 and 1, when you add them all together, you get 5. But once again, this is not really 5. It's going to be a 1 first power of 4 and another remaining 1 for 0 power of 4. And that's what makes you put that 1 in here, and then you carry another 1 over, and that's how you get 1, 1, 2. And that's exactly the answer they produced. So technically, you don't have to convert to base 10. You could just use these operations in base 4. So whichever one prefers better. So to me, it wouldn't matter how you do this, either use first way or the second way. It looks like second way is a little bit shorter, right? Because there I had to convert both numbers to base 10, then add them, and then I had to convert it back. So basically I did 3 steps. So here you don't really do 3 steps, but I guess it's a little bit different and it's kind of new. So let us try one more example. Just look at second example here and see how we could add the numbers in the base 2. And again, I'm not gonna, I guess, convert them to the base 10. I just gonna use this digits 0 and 1. And notice that what we're gonna need to use is powers of 2, right? Such as 2 to the first, 2 to the second, 2 to the third, and so forth. 2 to the third. So let us do this. This out loud. So I start with the last digit as usual, add those last digits, and they both have 1 in them. So when I add these, I should get a 2. But I cannot write 2 because in the base 2 we have only 0 and 1. So what's 2 in the base 2? Well, looks like we already did that little exercise last time, right? For quiz, and you all notice it was like 1, 0, right? So in fact, it's 1 first power of 2 and no 0 powers of 2. So this way I need to write down my last digit and carry over first. So that's how we add, right? We put last digit and then the first one we carry over. So now I add a couple of 1s. And notice I get 2 1s again. Okay, so I write down the last digit and carry over first. So technically same thing. So now I add 1 and 1 and 1. So now I get 3. So what is 3 in the base 2? How can I write it? And turns out it's 2 1s, right? Because we multiply the first by 2 to the power of 1 and the second digit by 2 to the power of 0. Okay? So when you have 1 for the coefficient with 2 to the first and 1 also for coefficient with 2 to the power of 0, you actually end up adding with adding 2 and 1, and that's how you get 3 in the base 10. So how can I write my answer then? Well, it should be 2 1s that I put here. So I have 1 as a result, and then I carry 1 over, and we get the actual number in the base 2 that looks like a couple of 1s and 2 zeros. And of course, you could try, if you feel like it, to rewrite both numbers in a base 10. In fact, why don't I return to the previous section where we had that little table so we could right away see what we have. Actually, I better copy my exercise because otherwise I guess I'm not going to be able to know what I'm doing, right? So I think it's here somewhere. So what I actually added was 3 ones, right, in the base 2, and then 1, 0, 1. And what I want to do is look at the little table we had in section 4.2. I guess in order not to spend a lot of time converting, but just to double check what type of numbers were given here. So I think this table is somewhere here at the bottom. And when you find this table, what you can do is try to locate the numbers we encountered here. So let me get it's cleaned a little bit. So first number that we utilized in this little sum was one designed from 3 ones, right? So this one, right? 3 ones. And 3 ones is right there, so it's actually 7. And then next we had 101, and 101 is 5, right? So that's what we had in reality. So we added the 2 numbers and we produced the answer is 12. And if you look at 12 in the base 2, it looks like 1, 1, and 0, 0. And that's exactly what we produced. If you can see here, 1, 1, and 0, 0. So we did that. So technically, if you're dealing with base 2, you can always look at this little table and convert the numbers to the base 10 and back right away. So let me go to some exercises on this section. And please notice here's the actual example they worked out. It took them the whole page to add this numbers. You can see the result is still the same, but I guess it's a good idea if you'll be able to redo problem on your own or try to read what they have produced. I think they have very good explanations here anyways. So what I want to do is maybe a couple of practice problems from this section. Notice besides adding, they also do other operations of subtraction and something else. So let me move to next page. That's where practice exercises are. And I'll do just addition and subtraction today. So maybe next time I will also multiply. So if you like, you can do the print screen of this group of problems. Let me first clean this. Let me clean this. Share screen again. So you can see this exercises nice and clean format. So yeah, you could do for homework problems on this page, and you can do the print screen for this. And also here's a little bit on the bottom. And I guess up to practice plus, there you have a little bit of problems in here. Notice they produced interesting little tables for multiplications, but as I said, I'll talk about them next time. Let's just add and subtract today. So I'm gonna try one exercise, and maybe I'll start with exercise in base 2. We just did look at the examples. So let me start with problem number 3 and add, as usual, last digits, they both 1. So when I add 2 ones, it's going to be a 2, but in a base 2, it's going to be a 1 and 0. So I put that 0 here and carry 1, right? So on the next column, I add 3 digits 1, so it actually looks like 3 in a base 10, but in a base 2, it's going to look like 11, right? 1, 1. Once again, the reason is that we have to the power of 0 here and to the power of 1. And first digit is 1, so I take it times first power of 2, and second digit is also 1, so that's number of ones. So 2 plus 1 is 3. So I write this as 1, 1, so I put down 1 and carry another 1, but since there is nothing, so just copy it. So 1, 1, 0. So adding in the base 2. Well, let's try one more. How about if I try to add bigger numbers, like ones we have in exercise 11. So those are base 7. So we're going to need to have powers of 7. So let me prepare these nice little powers of 7. 7 squared, and then 7 cubed, right? So please notice that we have 1, 2, 3, 4, 5 digits here. So we actually have 0 power, first, second, third, and the fourth. Well, so what are these actual powers? 49, and when you multiply 7 by 7 and by another 7, that was like 343, I think. Let us recall that. 343, right? 7 cube. Yes. Okay, so we're going to have 343. And as usual, we start with the last digits. Let's move it away so don't get confused. So put 343. So it looks like when I add my last digits 4 and 2, would I get 6? Is there such a digit in the base 7? And the answer is yes, because in the base 7 we have 0, 1, 2, 3, 4, 5, and 6. Right? Since base is 7 digits and base 7. So if you hit one of the digits lower than 7, it's fine. So you just copy it the way it is. Similarly, with the next two, when you add 3 and 0, you get 3. And yes, there is such a digit also in the base 7. So we're good here. But for the next, when I add 2 6s, so I get 12, I can't really have such a number in the base 7. So I need to write it using powers of 7. And looks like first power of 7 will fit there once, right? And what remains will be 5. So it'll be 5 times 0 power of 7. So this number is actually 1, 5 in the base 7. So 12, I put 1, 5. So I put, as usual, last digit 5. And I carry over my first digit, which is 1. Right? So next step will be to add 1, 4, and 5. And we get 10 in the base 7. So please notice I do add in the base 10, but I cannot write those numbers in the base 10. I need to use base 7. So once again, I fit 1 first power of 7, and what remains will be 3. So I get 0 power of 7 here. So we have 1 and 3 in a base 7. So I carry that 1 over. So I put down 3, right? And carry over 1. And finally, I add that one with the one in front. That will be something like that. And its number in base 7. Looks like 23 and then 536. And this is actually some other number in the base 10. And please notice I didn't even find what it is. I didn't really care for finding. I just added them purely in the base 7. I say, what if I do care? What if I actually write this in the base 10 and add? Yeah, you could do that also. It's up to you. Let me do one more, and then we'll try to subtract. So I'm looking at the base 16 right now, exercise 12. Remember base 16, they had digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But they also had 10, and they call it as A, right? Then B was present in 11, then we had C for 12, D for 13, E for 14, and finally F, which is 15. Since this is base 16, we need to have 16 different digits. And they produced A, B, C, D, E, and F. So it looks like that B is actually here. It's 11. So what you do is you add 11 with 4 and you get 15. And there is such a digit in the base 16, right? We call it as F. How about that? So notice that in the base 16, I think it's kind of nicer to add because we have so much room for those digits, right? So analogously, I do next addition of 3 and 9, and 3 plus 9 is 12, right? So I write that 12 in the base 16 as a C. Interesting, right? C. So then I move to the first ones and I add 5 and 6 and I get 11. And I can also write that digit in a base 16, it's B. So it's BCF. How would you like that? In a base 16. Isn't that just amazing? Some number that does not have any digits that we used to, right? Just letters. Okay, so as promised, I'm gonna do probably one exercise here for subtraction. So I'm gonna overwhelm you today with these because they're quite different compared to what you see in math classes. But I guess it's an interesting way to start the new week, right? So I'll do problem number 13, for example, when they want me to subtract things. And notice subtraction goes usual way. We subtract the last digits and then we move prior and so forth. And since I cannot subtract 3 from 2, I need to borrow, right? So how do I borrow? Well, when I borrow, then what remains will be 2 here, right? So I borrowed 1, 4, not 1, 10, because these numbers are in the base 4. So what I did, I borrowed 4. So I add that 4 with 2, and I get 6. And that's what I'm gonna be using for subtraction. So from 6, I'll subtract 3, And when I subtract 3 from 6, I'll get 3. And yes, we have digit 3 in the base 4, so I could just write down 3 and move to the previous digit. And my previous digit is 2 already because I borrowed. So I subtract 2 and 1 and get 1. So it looks like the number in the base 4 is going to look like that. Interesting. But Alex, can you check this out, convert them both to the base 10 and actually subtract and see how it goes? Yes, I can go that route as well, just to practice a little bit. So I want to rewrite 32 in the base 4 as a 3 multiplied by 4 and 2 multiplied by 1, right? So if I have this number 3 times 4 and 2 times 1. So the actual number is 12 plus 2, which is 14. So that's the one we're given for start. And we subtract 1, 3 from it in the base 4. And 1, 3 will again tell us that we have 1 first power of 4 and 3 0 powers. So this be 4 and 3, which is 7. So when you subtract 14 and 7, what you get is 7, right? 7. And notice that 7, we just saw how to write this in the base. It's 1, 3, so that's exactly what we actually produced. Just like that. So it's not really that bad, right, when you do these subtractions. So maybe I can do another one. Why not? Just one more. So move down a little bit and try to subtract numbers, let's say in the base 8 for a change. In base 8. So it looks like in a base 8, I'm going to have, let's say, exercise number 20, for example. So we'll start with borrowing. And when I borrow from 6, there'll be 5 only left, right? And when I bring this over to 2, so what I bring over to 2 is a 1, 8, right? So that's actually going to be 10. And that's what I'm subtracting 7 from. So notice I had to borrow because 7 is definitely larger than 2. And when I borrowed 1 of higher power of 8, which is 1, 8 to the first power, so it was just 1 of them, and put it on the top of 2, I ended up with a 10 in the base 10 system, and then subtract 7 from it. So when I subtract 7 from 10, I get 3. And continue the same process. So now I need to subtract 5 and 7, and 5 is not large enough, so I go ahead and borrow another from up here. So basically I borrow another 8. So what I do is I have 8 and 5 together, which is 13. And from that 13, I can nicely subtract my 7 and get 6. Okay, so now I move to the very beginning and I see that 3 and 1 that I can nicely subtract and get 2. And this is result in base 8, of course. So it's not 263, it's actually 263 in the base 8. And if you're curious to decide if you have what kind of number you have, well, you could definitely check it out. So I guess at this stage, maybe we have enough of that. What do you think? So next time I will be looking at the um, multiplications, and you can see there are also divisions. But to be honest, I think that multiplications you better do, and divisions as well, when you convert everything to the base 10 and then do these divisions, multiplications, and then convert them back to your base. I think it'd be more convenient, because otherwise it's a little bit too long to do. So again, you can do print screen of this page, so you can see what to practice, and practice classes we don't need to worry about. And notice it's not really very different compared to problems we have for regular practice exercises. Let's say if I'm looking at 39, then instead of two numbers, we have three numbers to add. So what? It's pretty much the same thing. But it's okay. I'm not asking you to worry about practice plus. I think you have plenty of practice here anyways. So I'm gonna